Okay, now we move on to the next sum. And as I said earlier on, prism, and we're talking about pyramid, we're talking about cone. All right, now I'm going to get a little bit different with the sector of a circle. All right, and let's see how this sum goes. There's going to be a deep realization of how a sector of a circle can be changed to a cone. This is a sector of a circle. All right, let's look at the sum. The figure below shows a major sector of a circle. This is the major sector whose radius is 21 cm. All right, whose radius is 21 cm. When the edges OA and OB are joined, a hollow cone is formed. Now this is the sector, just take note, OA, OB. When you join these two together, you get a hollow cone. Do you see that? All right, you get a hollow cone. And that's how they make your kacang putih container, you know what I mean? Your kacang putih, you eat kacang putih or not? Very nice lah. My days, I used to eat lots of kacang putih. Sometimes, you know, when going for a show and all that, buy one. But very fattening, okay? Take note. Alright, so what does the kacang putih man do? Take a paper like this. It's a part of a circle. And then, of course, he does that. And you seal these ends, and you get that. But of course, the real kacang putih man, of course, you will make it a bit smaller lah. Roll like that lah. Then you get less kacang putih in it. You'll get it? Okay, so let's take note of it. How's a cone made? Your waffle, when you go and buy your ice cream, okay, you want it on a cone. Well, what they do is they get this, it's a flat thing, and they bend it, and then they join this, you get a cone. Now what you learn here is that this radius of this sector is none other than what? Okay, you'll find out more. Let's find out the next part of the sum. They ask us, they said you form a cone, and this base radius of the cone is 14 cm, the base area of the cone. You're asked to find the slant length of the cone, this slant length, and the height of the cone, the height from the bottom right here, the height of the cone, and the surface area of this cone. All right, and the area of this major sector. You have to comment, and then you ask to find the angle LAOB. Now, my dear friends, as I just said to you, when we put this together, OA and OB together, the slant length of the cone is none other than the radius of this sector. So what's the slant length? The slant length is, hey, 21 cm. So that's the slant length. And what is the height of the cone? Now when you form a cone, all right, this cone, look at this, and the radius here R is 14 cm. You're given. The slant length is 21 cm. And the height of the cone is here. Okay, this is the height of the cone. Now what can you tell us about Pythagoras theorem? Do you see it? This is 90 degrees. And this radius here, the radius of the cone and the height of the cone, and look at the slant length, height, radius. So you can see that AR squared plus H squared is equal to L squared. All right, Pythagoras theorem, write it down here. And what does that work out to? Your R is 14 squared. Your height you don't know, but the length is 21 squared. So your H is going to be 21 squared minus 14 squared and a square root. Okay, you're going to work that out. And you can put it into your calculator, or you can do it like you want to be A squared minus B squared, 21 plus 45. Not that it's going to be easy. 21 plus 14, I'm afraid. Yeah, I'm going to write 14. And 21 minus 14. And you find the square root. This, you add them up, you get a 35. And this is a 7. And you want to find the square root. Alright, what is the 35 made up of? 5 times 7. Alright, 5 times 7 times 7. You find the square root. Alright, I just want to go through a little bit here. And the square root of 7 squared is 7. So your h is going to be this. When you have a square, you can take out the 7. And the 5 is not a square. You can't find the square root. Alright, so you can get this will be a square root 5. If they ask you, they said, hey, show. That's when you need, get a calculator to help you. If I add here, show that the height of the cone is 7 root 5. Okay, then you got to do it this way, my dear friends. R squared plus h squared is L squared. 14 squared plus h squared is 21 squared. You bring the 14 squared over, find the square root. A squared minus b squared. A plus b, a minus b. And 21 plus 14 is 35. Here's a 7. Break down the 35. 5 times 7 times 7. You get 5 times 7 squared. Now, my dear, if you have to find a square root of A, 4, B, 6, C, what do? You can do the individual. The square root of it here is an A squared. You divide the powers by 2. This is a B cubed. The C stays as it is. You got it? So here the square root of 7 squared is 7. The 5, you just leave it as a root 5. So take note of that. Okay, now otherwise, you put it into your calculator and get me your 3 significant figure. You get 21 squared minus 14 squared. Get the answer, find the square root, and you get 15.65. Your h is 15.652. Now, I would like you to test it. 7 times square root 5. What do you get? You also get the same answer. Right? Good. So you can keep, this is not a rounding up. You want to round up, 15.7 cm if they take 3 SF. Whereas this is the exact value. Alright, cm, put the measurement down. Exact value, because here there is a rounding up. Now, next part of the sum, the surface area of the cone. Now, when you will wonder, which one do I do? Well, the question paper tells you the 3 significant figures, well, do it to 3. If they don't, then you write what it is. What we want here in this particular lesson that we are doing, I just want you to know how to do these sums. I'm not really particularly interested in the exact values, but I just want to build up your mental strength, your quality of your maths knowledge, all right, in terms of area and volume for this, all right? So Maths with Kumar is about understanding, not forgetting, remembering it a lifetime, teaching maths to your grandchildren. You will be a grandpa and a granddad one day, but that's years to wait, all right? Now let's look at the next thing. We've got the height of the cone. Now they want to find the surface area of the cone. What is the surface area? What's the formula for the surface area? Do you remember it? The curved surface area of the cone is none other than pi RL. So the curved surface area of the cone, let me write here. The curved surface area of the cone is pi RL. And you've got all that formula with you. The pi, the radius is given 14, the slant length is 21, and all you need to do is to multiply 14 times 21, all right, times pi. So look at it, 14 times 21, get your answer. You get a 294 pi cm squared. If you want the actual, this is the actual answer without rounding up. If you need to multiply and get to 3 significant figures, it will be 923.6. All right? So surface area is 923.6. I wanted 3SF will be 924 cm squared. All right, please make sure you write the units of measurement. That will be the curved surface area of the cone. Now the curved surface area of the cone is obviously the same. Let's find out the area of the major sector. How do you find the area of the major sector? This cone came from these two sealed up, and this is the curved surface area. If I cut this off, I will get this sector here. And the curved surface area of the cone is none other than the area of the sector. Are you clear? So we look at it and we said, A, area of the major sector. What are you? The area of the major sector is going to be, this is the major sector here. All right, the area of this major sector, AOB, is going to be same, similar. All right, we look at it, it is going to be 294 pi cm squared, or 924 cm squared, because we saw it visually what it is, and comment because they are the same surface area. That's what you have to know. Common sense. And normally, what is the formula for the area sector? The area sector is given by, all right, angle over angle. The angle is 360 degrees, all right, angle. And I want to put angle, I'm going to put it as x or theta. If I put theta, if you're comfortable, good. All right, theta over 360 degrees is the area of sector over pi r squared. All right, but we don't know this angle. We can't use this formula. All right, if you don't want to use it, this is in degree. If you put it in radian, angle over angle, this will be 2 pi. The angle here must be in radian. Radian over radian. Area of sector over pi r squared. To find the area of sector, well, you bring this up. All right, and so what you got, the area of sector will be theta over 2 pi times pi r squared. You could cancel it. What you've got is the area of sector equals to 1 over 2 r squared theta. That's the area of the sector. Now please take note why I put theta at the back, because theta is too tall. All right, even in alphabets, we choose to respect tall, go to back, shorter, r squared goes there. What we did is we brought pi r squared up, theta over 2 pi, all right, theta over 2 pi times pi r squared. Cancel this off, you get 1 over 2 r squared theta. But of course, the condition here must be the theta is in radian. Now, if you are in Sec 2, you may not have learned radian. What is radian, if you're wondering? Well, radian is something, it's the same unit of measurement, 180 degrees is pi radian. Okay, that's the meaning of radian. 180 degrees is pi. But your unit of measurement, when you use a calculator, all right, you have to turn to your radian mode then. If you can use for sine, pi, all right, you have to put it in radian mode. Now you want to find angle AOB, all right, and you know the area of the sector, and the area of sector is, I would choose 294 pi cm squared, and I say, hey, that's your area, and we want to find out the angle. All right, we can do it in degrees or you can do it in radian, not a problem at all. And they want this major sector, so this is the angle. And let the angle be theta over 360 degrees equals the area of sector 294 pi. We get the exact answer, area of sector which we have, and this angle here is called theta, all right, over pi r squared. And the r squared is here, the r is 21. So area of sector, we're using this formula, my dear friends, angle over angle, area of sector over the area of the circle. This pi r squared is the whole circle. We could cancel the pi off, and we want to find out We know r is 21, so your theta is going to be 294 over r squared. R is 21 squared, and you bring up the 360r, and you could work that out very comfortably, all right, using a calculator. Not all the time I would advocate you to use your human brain, although it's really good, all right, divided by 21 squared. And you get the angle to be 240 degrees. Wow. That's your answer. All right, 240 degrees. So that's the angle, therefore angle AOB. Angle AOB, this angle here is a reflex angle, and therefore angle AOB of the major sector is 240 degrees. If you want to change it to radian, it's not at all a problem. 180 degrees is pi. 1 degree, what's 240 degrees? You find for 1 degree first, you divide by 180, and then 240 degrees, you multiply by 240. Find for 1, divide by 180, 1 degree is so much. 240 degrees, you multiply by that. Ding ding. Divide by 6, this is 3, 4. So you get 4/3 pi radian. That's your answer for your theta. Right? Angle. Alright, now this is about angles. Alright, you have a sector and you're asked to find, okay, you have the figure below shows you a major sector, and they tell you that it is 21 cm, and it wants you to put it into a cone. Very easy concept. You've got a sector. When you put these two together, the sector is changed to a cone. It's a very popular kind of sum, common knowledge. Please take note of it. And this slant length, the slant length of this sector is none other than the radius of this circle. The radius, they are both the same because the center of the circle, and this is a sector coming out from the circle. So the slant length of the cone is none other than the radius of the sector. Now this radius here, the radius, the cone, all right, please take note. All right, look at that, the cone, and times the height. All right, you look at the height here, I mean radius, and that's the height. You know the Pythagoras theorem, r squared plus h squared equals to L squared, the slant length. And from there, you know this radius that's given to you. You know this, you could work out the height of the cone. I told you that's the exact value. This is the, approximately we are working out closest to. Now, once we've got the height of the cone, we want to find the surface area of the cone because this is a hollow cone, hollow. So what's the hollow cone surface area? Pi RL. But with a solid cone, what do? Solid means it's all full. So you got to find the surface area plus the area of the base, which is pi r squared. So a hollow cone is just pi RL. Please don't tell me, I don't know, I forgot. Very simple, my dear friends. These are simple things you need to know. The surface area of the cone is pi RL. Alright? So what we do, we say, hey, pi RL, the radius is 14, the slant length is 21, and you get 294 pi cm squared. That's the exact value. And then you put into your calculator what's pi. Pi is about 3 times more, 3.142. You work it out, you get 924 cm squared. Now the surface area of the cone is the same as the area of the sector. Alright? So if you were to find a formula for the area sector, we can't be able to do it. That's why you're going to have this common knowledge. They're the same. Why comment? They're the same. Hello. So the area of the sector will be the same, and that sector will be 294 pi cm squared. The area sector, 294 pi cm squared. Why? They are the same area, same. Alright? Now you need to find out the angle of this sector, major sector. You got the area. All right, and I took 294 pi. It's so much easier because I could cancel the pi off. Angle over angle equals to area over the area of the circle because it's about proportion. All right, small angle, big angle, small area, big area. All right, it's the same circle. So the bigger the area, the bigger the circle. So look at that. So 360 degrees will be the area of this whole circle. So look at that, and we worked out. Bring the 360 degrees off, the pi has a natural death. Pi, pi, die. Pi, pi, die. Gone. So we've got that r squared, which is 21. Put it in. Ooh, we've got 240 degrees. All right, that's question 4. And now the last sum, question 5, will be quite a challenge. I'd like you to take a little break, refresh yourself and exercise. All right, you want to have a quick dance? May do so. Oh, and you want to relax, have your eyes shut, why not? All right, and come back to question 5. It's kind of interesting. See you.